Okay, hello. So for some reason I recorded this, but it didn't record. So you may want to pause the video and write this down, and then we're going to continue and finish this. So this is the last example I want to do with this second case that we were talking about. And so here we have the integral from 0 to 2 of dx over x minus 1 to the 2/3. And notice at the endpoint 0 and 2 that the function is continuous, so you have to look for a value. So think about the domain and at 1. Now it doesn't have to be always have to be the number that's dead in the middle of your endpoints. It could be any number in between your endpoints, so just keep that in mind. Your goal is to figure out what the domain of your function is and if there are any bad points, so any inputs that won't give you an output. All right, and so since 1 it would be our vertical asymptote, or this where our function would be discontinuous, we break it up from the integral from 0 to 1 of dx over x minus 1 to the 2/3 plus from 1 to 2 of dx over x minus 1 to the 2/3. And now I'm just going to use r because, again, I don't want to confuse you all, and I don't want you to spend too much time trying to figure out, oh, should this be a or should this be a b. You can just use r as for both of these integrals. Again, it's important to understand what you're taking the limit of, not necessarily what letter you use. Okay, so we have the limit. Since we're going in this first integral from 0 to 1, it's the limit as r approaches 1 from the left. Okay, so if you think about, we're looking at it from 0 to 1, so that means you want all the values to the left of 1 in this interval, in this integral of the integral from 0 to r dx over x minus 1 to the 2/3, plus now we're on the interval, we're looking for 1 to 2, so we want the limit as r approaches 1 from the right of the integral from r to 2 dx over x minus 1 to the 2/3. Okay, and that, so actually before we get to that answer, I just have an aside. So again, this is just a quick review of antiderivative. So we look at the integral of dx over x minus 1 to the 2/3. We use u substitution, like u equal x minus 1, du equals dx. So then we get that, the integral of du over u to the 2/3. And we know we can rewrite that as the integral of u to the negative 2/3. So we can, okay, so let's see where I left off. So using the power rules for integral, that'll give us u to the negative 2/3 plus 1 over negative 2/3 plus 1. And that simplifies to 3 times u to the 1/3. And of course, rewrite that back in terms of x. So that's what our integral, our indefinite integral, becomes. So now let's go back. And that's what this part is. Okay, so this equals the limit as r approaches 1 from the left of 3 times x minus 1 to the 1/3 evaluated from 0 to r, and plus the limit as r approaches 1 from the right of 3 times x minus 1 to the 1/3 evaluated from r to 2. Okay, now like I said before, I would evaluate it one at a time, because once we evaluate this first term, after we evaluate it, if that diverges, then we can say the whole thing. We don't have to do the other term, evaluate the other term. Okay, but if it converges, then we do have to figure out the other term. Okay, so I'm not going to put an equal sign because we're just going to evaluate. So this will be the limit as r approaches 1 from the left of 3 times r minus 1 to the 1/3 minus 3 times 1 minus 1 to the 1/3. I'm sorry. That should be 0, right? Okay, I knew something looked funny. All right, 3, 0 minus 1. Okay, to the 1/3. And let's just look at this. We can look at this to evaluate it. So here in this first term, we have, that's just going to go to 0, right? Because r approaches 1 from the left, so that's just going to be 0. And then here we have negative 1 to the 1/3, which is actually the cubic root of negative 1, which is negative 1 times negative 3. So that's going to be plus 3. So it's a finite number, which means we need to continue simplifying the other. Okay, integral. And so let's look at the other one. So now we could put plus the limit as r approaches 1 from the right of 3 times, trying to squeeze it all in here, This time, though, it's 2 minus 1 to the 1/3 minus 3 times r minus 1 to the 1/3. Okay, and over here, so now we can put an equal sign. This first term is going to be 2 minus 1, which is 1. 3 times 1 is 3, so that's 3. And then r minus 1, so r is 1, so that's just going to go to 0. And so we have a final answer of 6, which tells us that our integral converges. Okay. So again, make sure you go back over these examples. I will post homework for problems from this section, which is still 7.6, but particular problems like this, so you can practice.